In this video, we are going to discuss the law of cosines. So unlike the law of sines, which was a ratio where we could set up proportions, the law of cosines is going to be a formula. So each of these formulas are identical to one another. The only difference is basically just the side that you were trying to solve for and the angles. So basically what this is saying is that the side you're trying to solve for, so in this case we have A. So A is going to be equal to, or A squared is equal to B squared plus C squared. That kind of sounds familiar. That's basically the Pythagorean theorem, except you know it as the C squared equals A squared plus B squared. But here we don't have a right triangle, so there is no hypotenuse. Except we have this subtraction of the 2 times both of those sides times the cosine of the side you're solving for angle. So here we have a's. So in our equations we have a squared. In the second equation we have b squared, and we have the angle of b. And the last one, it's c squared and the angle of c. So basically what this is just telling you is if you are trying to solve for a side, you need to know that side's opposite angle. So there are 2 types of triangles that will help us solve this law of cosines. It's side, side, side. So if I'm given side A, side B, and side C, I can solve for the angle. Side, angle, side. So basically what you're seeing right here where we have side B, angle A, side C, I can go and I can solve for that angle of A using this formula. So we're going to start with side, side, side triangles. So the thing with side, side, side triangles is that we need to first check to make sure that it actually forms a triangle, because not all sides would connect and therefore we just wouldn't get a triangle. So to check this, all you have to do is check the small side plus the medium side, and that just needs to be greater than the largest side. So it has to be greater than. I'm not saying equal to. If it's equal to, that's also not a triangle. It has to be greater than. So anything greater than the largest. So in this example, the smallest of these 3 sides is 2. The middle would be 3. And the greatest would be 24. So 2 plus 3 gives me 5. And is 5 greater than 24? No. So this would not form a triangle. So anytime you are doing side, 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 you should do that quick check first. Otherwise, you're going to start doing work and you're going to realize that your answers are just wrong and you basically did work for no reason at all because there was no triangle to even begin with. So here on this example, let's quickly check to see whether or not this would form a triangle. So we have 24 plus 18, and we want to see if that is greater than 40. So we get out 42, which is greater than 40. So this would form a triangle. So now I just need to solve for the triangle. And since I'm given a bunch of sides, what I'm going to do to start is I'm going to draw a triangle. So I'm going to start by drawing some kind of triangle. So this is going to be A, this will be B, this will be C. So that means the opposite side of A is going to be the lowercase a, which is 24. The opposite of B is going to be that 40. And the opposite of C, angle C, is going to be the 18. So now that I have this, what I want to do is I want to set up one of the equations and solve for one of the angles. Now, here is a note for solving side, side, side. Always solve for the obtuse angle, or the what would potentially be the largest angle. So always solve for the largest angle first. And the largest angle is going to come from the largest side. So here I have the 40. So what I want to do is I want to solve for this B. So I am solving for B because it is opposite of the largest side. So there's reasons behind that. We'll talk about it in class, but the important thing is always just solve for the largest side first. So that means since I'm solving for angle B, that means the equation would have been B squared equals A squared plus C squared minus 2AC times the cosine of that angle B. So again, the side, so I'm looking for angle B, so that means that its side is going to be on the opposite side of the equal. It's the other two sides squared minus 2 times those two sides times the cosine of B. So I know the sides of A, B, and C, so I'm going to start plugging things into the equation. So we know that side B is 40, so this will be 40 squared equals A squared, which was 24 squared. C squared is 18 squared minus 2 times that 24 times that 18 times the cosine of B. And this is what we are solving for. We are trying to solve for this B. So since I'm trying to solve for this B, I need to isolate it. So to isolate it, I first need to start simplifying things. So I'm going to start simplifying all the squared, and I'm going to do this piece of multiplication over here as well. So 40 squared gives me 1,600. 24 squared is 576. 18 squared gives me 324. And 2 times 24 times 18 gives me 864 times the cosine of the angle. So at this point is going to be where if you make a mistake, it is right here. We're going to add our like terms on the right side, but the only two things that we can add together are these things right here, because we have the cosine is being multiplied to this 864. So you cannot add these things together. This just is going to stay how it is. So we have 1600 equals 576 plus that 324, so 900 minus 864 times the cosine of B. So now I'm going to solve. So to solve this, I'm going to start by subtracting 900 on both sides. So that gives me 700 equals a negative 864 times the cosine of B. Then I'm going to go and divide both sides by that negative 864. So at this point, this would cancel, and I'm going to keep it as the fraction for right now. So I have 700 over negative 864 equals cosine of B. So at this point, since I'm solving for this cosine, or this B, and it's inside of the cosine, I'm going to take the inverse cosine of both sides. So taking the inverse cosine of 700 divided by negative 864, close that parentheses, and I get the angle of 144.11 degrees. So I have now found the angle here. So 144.11 degrees. So now I just would need to find the other two. So as you can see, this is the complicated of the law of sine or the law of cosine. Law of cosine is always the more complicated. There's more work involved with it. And you only ever do law of cosine one time. After you've done it, you can do it for all of the other angles. If you really, really want to do that with your life, that's cool. Otherwise, now we have a completed ratio. So since we have that completed ratio, this is a perfect law of sine problem. So I'm going to now come over here and I'm going to solve for the next piece. So we can set up our ratio since we know that we have this completed ratio of 40 and the angle of 144.11 degrees. And I need to solve for either of the other two angles. I'm going to solve for angle A. Since I'm solving for angles, I'm going to actually put the sine of that 144.11 in my numerator, and the 40 is in the denominator. And since I'm solving for A, A's side was 24 and the sine of A. The reason why I'm flipping the law of sine is so I don't have to do more work later on. I actually can do less steps because of this. So anytime I'm solving for an angle, I'm going to put those signs in the numerator and the sides in the denominator. So here, since I'm solving for A, it's being divided by this 24. I'm going to multiply both sides by 24. So those would cancel. And then the last thing I need to do is I need to get rid of the sine. So I'm just going to take the inverse sine of both sides. So I'm going to take the inverse sine of this entire thing. So I'm going to put that in my calculator in just one go. If you need to do it in multiple steps, you can. So I'm going to do the inverse sine of 24 times the sine of 144.11 divided by 40, then close off the parentheses for the inverse sine, and I get out angle A is 20.59 degrees. So I now know that angle A is 20.59 degrees. So I just need to find angle C, and to find angle C, I could do the law of sine again. I could do the law of cosine if I really wanted to, but the interior sum of any triangle is 180 degrees. So I'm going to use that fact to solve. So we have angle A, which was 20.59 degrees. We know angle B was 144.11 degrees. I'm trying to find angle C, and altogether it needs to add up to 180 degrees. So I just need to add those things together. So, and then subtract it. So we have 164.70 plus C equals 180. So subtract that on both sides. And I get that C equals 15.3. So I'm going to come back over here, put that in that triangle. And a good check here is to make sure that the opposite sides and their angles make sense. So like the largest side is also the largest angle. The second largest side is the second largest angle. The smallest side is the smallest angle. That makes sense. So that is just a quick logical check to make sure that you potentially did the problem correctly. So on a problem like this, it's do the law of cosine one time. Once you have that angle, you now have a completed ratio, so do the law of sine. After you have that second angle, use the interior sum equals 180, and you have now the rest of the triangle. So I have a you try for you to try. So take a couple seconds, pause this video, and try it out. All right, so for angle A, you should have gotten 34.05 degrees. For angle B, you should have gotten 44.41 degrees. And for angle C, you should have gotten 101.54 degrees.